Welcome back to the class. Now we will talk about calderas. These calderas are again another geological structure found in volcanoes after volcanic eruptions. What happens? These are those bowl-like structure, and these are generally over 1 kilometer in diameter. If it is smaller than 1 kilometer in diameter, then we call it a crater. These calderas are generally formed when the summit collapses following the drainage of magma chamber. So the idea here so if you have a mountain summit like this and you have a magma chamber here, right? So it is building, the magma is rising up, and over the year this magma will eventually release over here, right? And what will happen, this release will continue until this magma chamber empties. So once this magma chamber empties, this cannot hold itself and it will just simply collapse under its own weight, because there is nothing underneath here to hold the weight of this crater. So this will just simply collapse, and if the size of this crater is more than 1 kilometer in diameter, then we call it a caldera, and if it is smaller than 1 kilometer, then we call it just simply a crater. So this is the idea behind caldera, and there are three different types of calderas. First one is crater lake type caldera. There is one example in state of Oregon. So here is the schematic here, the process that leads to the formation of this crater lake type caldera. So just like here you have a magma chamber, and these are just the vents, the plumbing system that develops over the year by means of fissures and fractures that develops in the crust that allows these magma to rise toward the surface. And eventually a time will come when the magma chamber has enough pressure to completely explode through this volcano with force, and that is when this magma chamber will starts to empty. So this is what you see here, that magma chamber has released all its magma and it has just erupted here, and then now this overlying structure, which you can call crater, it cannot sustain its own weight because the chamber underneath is empty. So it will collapse under its own weight, and now over the years after the collapse of this crater, this crater will be filled with water, rainfall, and snow melt. It's going to fill it, and then there may be another very minor volcanic event will happen that will develop this cinder cone like structure. So now you have a lake, this large lake, and then there you have a small island like a structure in the middle of lake. So this structure is currently present in the state of Oregon. And this one is called as a crater-like caldera, and this is called calderas because it is about 10 kilometers wide, and this event happened about 7,000 years ago in the past. So this is one type of caldera. Another one is called as Hawaiian type caldera. So this is another example. I'll just draw another mountain here, and what will happen here, also you have a magma chamber. Okay, so you have magma held there, but what happened in this case, we have lots of these fissures. It starts to develop on the side of the mountain, and that will allow lots of these magma to be released on the side. Okay, it's not gonna erupt from the top. It's not going to be a violent eruption. Instead, there will be these small vents that will over the year develop, and these magma will continue to erupt out through these vents, and that what will happen, that this chamber will start to empty, and that will cause the collapse of this this summit of this mountain. So then it will collapse, and then you will have a caldera being formed here. And over the year, this size of the caldera will continue to grow because you have more and more magma is emitted or coming out of this structure. So the volume or the size of this caldera will continue to grow, and it will look like a shield shield, like a warrior shield. So that's why it is also called as a shield type volcano. But based on the size of this crater, it is called as a Hawaiian type caldera. This is very commonly found in the state Hawaiian island, like Mauna Loa or Kiau. Those are the sites where you will find this kind of calderas. The third kind is called as Yellowstone type caldera. This is currently present in Yellowstone National Park, and here this type of caldera is very vast. It is about 70 kilometers in diameter, and this come into existence after multiple occurrences of volcanic eruption. So it's not as a result of one volcanic eruption, but multiple very large violent explosive eruption that will lead to formation of these kind of Yellowstone type calderas. Here in this schematic, it is showing the lava that erupted and how far it flowed from the site of eruption. So here, this one, the black dot, here it is showing the site of eruption, and here you have three distinct events of eruption that has occurred. The most recent one is about 640,000 years ago. The one after before that was 1.3 million years ago, and the first one was about 2 million years ago. So you can see that the volume of lava that was erupted during each of these eruption has grown significantly over the time. So the most recent one has covered the entire central US, from all the way from north to south, across the entire continental US, you could say. So this is the site of eruption, and some of the lava and magma has found its way all the way into the Gulf of Mexico. So this is how strong the eruption was, that the lava could flow all the way down south to the Gulf of Mexico. And this is here just for comparison. It is showing here the scale of eruption in the most recent history, Mount St. Helens in 1980. So this pales in comparison to any of these eruption at Yellowstone National Park. So after the event of eruption, again the summit of the mountain will settle, because the magma chamber has emptied itself, so it will just simply collapse, and you have these resurgent dome here forming here, and those resurgent domes form when you have magma chamber building underneath, and it's tied to kind of push the ground upwards because of the continuous build of the pressure. So you have these two dome like structures. It's a relatively elevated structure on the ground compared to the surrounding neighborhood. So there are two resurgent domes, so that indicates there are probably very nearby two different plumes, or just one plume which has found the plumbing or the escape route was such that it was able to create these two resurgent domes. And there you have these rivers passing over these two resurgent domes, and these creates a very strong rapids around this area. So this is a very common site for recreation. Lots of people visit Yellowstone National Park every year, and lots of people even go into these rapids for recreational purposes. So this is a third type of caldera, and I have uploaded some video as well, so please feel free to browse through them. That will give you more animation and videos. This itself is a smart figure in your textbook, so also you can go to this website to see more detail about this Yellowstone National Park and the event of eruption that occurred at this site.